Hello everyone. Today we'll say about the estimation of for software project. This was a requirement for many of you, so that's why I'm going through it again. It's a very interesting thing which we'll discuss today. And we already know that we have a size-oriented matrices, problem-based matrices, and among the size-oriented matrices, we talked about the LOC-based estimation. So you just see we have a size-oriented matrices problem-based estimation, which is LOC and FP. So let's jump into our LOC-based estimation, this example, which you already discussed. But to let you know that to do this chapter, which is in chapter 33, estimation for software projects, you need to go through chapter 30, 31, 32, and 33. So all these are distributed into these three chapters. And finally, we reach to this estimation chapter. Let's see what happened over here. You have already done the DFD. And in level 1 DFD, if you remember that we decompose our system into some subsystems. And this is an example where it says that for any software, if you consider that these are your key functions, and all these key functions or key processes has got, these are the total estimated line of code. So we do not know, we cannot say directly about I need 2,300 lines for these functions, or 5,300 lines for that functions or that processes. So what we had a probabilistic structure. So we can say that I may need 1,500 lines minimum, on an average 2,000 line, maximum can be 2,500 lines. So if we have this sort of confusion, so we can use this formula, which is this one. So same formula we'll use also in the FP, that is optimistic value plus 4 into most likely plus pessimistic whole divided by 6. So this is this gives us an probabilistic value for estimated value for some function lines of code. So these values are actually coming from this. So we will say this is an estimated line of codes for each of these functions. So we have 1, 2, 3, 4, 5, 6, 7 functions. Our 7 key processes basically are here, which you can refer to your DFD level 1, where you decompose your base system to key subsystems or key processes. So if you see, we have 7 processes or 7 functions over here, and these are the LOC, the line of code for each of them. And in total, we have 33,200 lines of code. Then how we'll get it? So we got 1 unit from there. And here we said about an organization that is a standard organization. They have some LOCs for their organization. So every organizations are unique. So they have a different LOC, and this LOC will tell that is how much budget actually they are required for their organization. So here we see that we have a standard LOC for 6,200 LOC per month. And this can vary to different organization to organization. So some can have 700, someone may have 800, someone may have 500. So it depends. So, and another one is that the labor rate, that is the cost of the programmers, which is here it says $8,000 per month. This also varies from different organization to organization. So if we take these two values for our calculation, So it is based on your area's programmer's rate or who are working into this software project. So their average per month cost you will calculate, and then you put this value over here. So what will happen? So what we do over here, we will try to find out the man month into our estimation and also the estimated cost. These two is our target. So what we do, we got this value, which is the organizational standard, and we also got the organizational average programmer cost or labor rate. So what we do, if we have a total estimated line of code is 33,200, which is divided by our organizational standard is 620 LOC per month, that is line of code per month. So we got 53.54 months, so which is actually our man month. And here you'll see they round it on 54 man months. So we got a 54 man month over here. And once we got a 54 man month, this is one is our target. Another one is we try to identify the cost. So if we know that we got, this is our value, that is 8,000 per month. So if we also try to identify the per line of code, what would be the cost of per line of code? So if we divide 8,000 divided by 620, we got 12.90, which is approximately $13, which is also given over here. So we got $13, and if we multiply it with our actual value is 33,200, we got 4,28,387 the total cost, and which is approximately 4,31,000. So if we do it again, 33,200 into $13, with the $13 we got 4,31,600. So they give $600 discount over here. So but we got around for this. We can also find this value by using this man month. The man month, we got 54 man month. That means 54 person needed for this project if we want to complete it in 1 month, or we need 54 months to complete the project if only one person do work in this project. So man month tells us this thing. So we got 54 man month into our labor rate is programmer cost is 8,000. So if we got around 4,32,000. So we got 53 point something. So if we multiply with that one, we actually get 4,33,000. So this is our LOC based estimation. We have another estimation process which is called FP estimation process, function point estimation. In function point estimation, we have to use this table, and this table tells us the information domain value. So we have 5 information domain variables, which is number of external inputs, number of external outputs, number of external inquiries, number of internal logical files, and number of external interface files. And all these things you will also find out over here in our in chapter 30, because I said that we need to go to these chapters because these chapters are actually related with this. So in product matrix, all the matrices actually discuss over there. So this number of external inputs means what? So everything is there telling over here. And number of outputs, external inquiries, number of internal logical files, external interface files. So if we have all these things, we can write over there. And also you'll see, so we got number of external inputs of a function or the whole software or all the one of the process. You can consider that you have a minimum value. Optimistic value is 20, most likely you give 24, pessimistic value you identify 30. So you do the estimated count value. Same estimated count value is our that probabilistic formula. This formula is used for these purposes. That is optimistic plus 4 into most likely plus pessimistic divided by 6. So from there we got a estimated count value is 24. So you got some fractional value. You got some fractional value which is 23 point something. So they round it here, and all these values are over here. So we can also eliminate the decimal points and make it a round figure. Then this part is very important, interesting. Where we get this weighting factor value. This is called weighting factor values. Based on the size, complexity of the project, we set these weighting factors. So which is also given reference to our chapter 30. That is weighting factors for a simple software are this. Weighting factor for an average software are this, and weighting factor for a very complex solution or software are this. So based on these three criteria, we will put this value. So 4, 5, 5, 10, 7. So I think this is an average value. So this is an average one. So they find that this is an average software. So where they put these weighting factor values. Then we have to multiply this value, weighting factor, into this. We come the FP count value. So it's actually not 97, it's 98. But due to fractional point, they make it round something like this. So you can take any value, no problem. With decimal values are more accurate. Without decimal values are some differences are there, but it's not that big difference. It will not create big difference over there. So if we multiply this, we got this, and this is the summation of total count. So we make a sum of all this. So which is our summation of FP count. Then we use this particular formula. So we got this count total from here, then which is multiplied with 0.65 into plus 0.01 into summation of Fi. This is complexity adjacent factor, which is called complexity adjacent factor, which are this. So we got 14 questions. We have to ask 14 questions for each of the functions, and we have to rate it from 0 to 5 scale. We have to rate it to 0 to 5 scale. And we say that, do we need any backup and recovery? So again, we need to go back to our chapter 30, where these complexity adjacent factors questions are there. So does the system require reliable backup and recovery? So are these distributed processing functions? So all these 14 questions are given over here, detailed questions. So here some of the short part of the questions is given. So if our software need any backup and recovery, you give a value, you put a value 0 to 5. If it needs a distributed processing, so you give value. If it does not, you give 0 value. So the scale is 0 to 5. So you give all this, and you have to make a summation of it. You have to make a summation, and that summation will be added with 0.01. So you got this thing, and then you find the value which is called 1.17. So the summation value you multiplied with 0.01, which is multiplied, then you plus this value with 0.65. Then you got this value. So if we have this value, we got a count total of 120, 320 multiplied by summation value is 1.17, which is 375 FP. So our final estimated FP is 375. So 74.5. So they got 375. Then how we make it, find the man month and calculation of it. So same thing, for the FP, there is also a standard. Let me use another color. Okay, so there is a standard also taken for different organization to organization. It varies. So it is the organizational average productivity. So it is the organizational average productivity. So which is 6.65. Some organizations productivity can be 7. Some organization productivity can be 5. Some organization productivity can be maybe 8, 10. So it depends on organization to organization. And we keep the same programmer's rate, which is 8,000 per month. So if we do the calculation, because our target is to find the man month and cost. So let's jump into the system. So, so if we find that our AP is 375, and these organizations productivity is 6.5 FP. So let's find out what is the cost of per FP. So, and the monthly per month cost is $8,000. So if we divide $8,000 into 6.5, we got 12.31.76. That means $1,231 for per FP. So we also got $1,231. So they did not make it round. They keep to $1,230. And then we got if we have 1,230 into our total AP is 375. 375. We got 4,61,000. So we actually got $4,61,250. They give discount of $250. So they said our cost is $461. $4,61,000. Sorry, it's a $4,61,000. So in this way, we calculate, we try to find the AP and man month and cost for this software by using the AP method. Another one is a process-based estimation. In a process-based estimation, it is also very interesting. In process-based estimation, let me zoom it. Yes. So these were actually our framework activities, but right now we got 5 framework activities, but these were actually the 6 framework activities. So same way, we have all these activity list over here in this table, and we have some tasks. We have tasks for engineering is divided into 2 parts: analysis and design, construction and release divided in coding and testing part. This CE is customer evaluation, so we do not calculate the cost of customer evaluation, so that's why it is not applicable. Same way, we have all these core functions. You can see all these functions are there, core processes, and then you say what is the how much time you take. So here you have to find out 0.25 equal to 6 or 5 working days, because we do not work 7 days a week. So based on the organization, some organizations said we have 6 working days in a week. Some said we have 5 working days in a week. So based on that, you have to consider the 0.25 is the unit of this, that is working days in a week. So 0.25. So you will calculate, or we'll calculate, that is how much time we do this communication part. So here in total, they said we take 0.25. That means 6 working days or 5 working days. You can also make it in individual. If our project is big, for each of the function, we can take individual time period for communication. If it is a big project, complex project, so for each of the functions we can take, and all of this summation will be this one. So as we do the communication for this small project together, so we said we need 7 days for this, or 6 working days, or 5 working days for this thing. Same thing for the planning also. We considered, we take 0. We did 7 days or 6 days for planning part of this project, and in total it is 0.25. So if you take 10 days, if your standard is 5 working days, and if you say 10 days, so it would be 0.5, because 0.25 equal to 5 working days. So it based on the organization to organization, this value may changes. Then risk analysis also in total we'll consider, and we do it. We can do individuals as well. Then in engineering part, you just see for analysis of this project, it takes 10 days. So in 10 days, it takes, which is 0.5. It may take 15 days, so it is 0.75. So in total, analysis takes 3.50 days, because our unit is 0.25. Same way for designing, we do all these things. Some takes months, so some of them are in months. So 4, 5 weeks. So all are in months. So we got 20.50 in total time period. For coding also, we have all these points, and these points tells us that how many weeks actually we need, working weeks we need for this particular activities. And then we find it is total is 4.5. Same for testing as well, that how long it take for testing, how many weeks it takes, and we got total 16.50 the value. So if we add all these value, we got 46, and this 46 is basically our man-month. So in process-based estimation, we calculate the time, and with the time we also find this man-month directly, because this gives us how many times actually required for completing this work. So we got 46 man-month, and here we also see there that are some efforts are there, that how the efforts are distributed. So if you consider your total, if your total task is 46, and if you want to do for maybe for testing is 16.50, so what you will do? So if you try to find out the effort is 16.50 into 100 divided by 46. So you find 35.86, which is 36%. So same way for testing the total project effort from 100%, from total 46 is 100%. This is 100%. So total 36% is taken to our testing, 10% for coding. You just see only 10% is for coding, 45% for designing, 8% for analysis. So major activities are actually taken to the analysis and design, which is around 53% of the total task is taken. Then coding takes only 10%, 36% for testing, and these are taking 1%, actually less than 1%. They make it round for 1%. So once we get the man month, so same thing also over here. We got 8,000 per man month. So if we directly calculate, we got 46 man month into 8,000. So we got $368,000 for this project. So here we got $368,000 as our estimated budget for completing this project. So in 3 different estimations, we basically got the prices. So our estimations are here. We got 4,61,000. In previous one, we got in LOC based estimation, we got 4,31,000. So all these are giving us an idea that what would be the estimated cost for completing this project, for completing this particular project. So I hope that this example and this calculation will help you out that how to do the estimation, and it's really a fun. It's really a fun to do it. Only you need to know in which chapters you have to move around to get your clear idea. So for people management chapter is also important because labor rate, you have to check your local area's labor rate, your programmers rate, or who are involved into the software. So in different country wise, it is different. So you can find the software, you go to different software organizations and try to collect their salary range. And from there, you can find a rough estimated cost for your project. And this is how we do the estimation. And I wish you enjoy it, and you can solve many of your problems, real life problems, and you can also solve, apply these things in your projects, in your organizations where it is required. Thank you all for listening all through. Thank you very much.